Hello everyone. In this lecture, we will be seeing the second property of functions, that is bijection of composition of functions. If the functions f from a to b and g from b to c are both 1, 1 and onto. So we know that it is possible to define G composition F from A to C, because observe that the domain of G, that is B, and codomain of F, B, both are same. So this composition map exists. This composition map will also be 1, 1 and onto respectively. That is, when F and G are 1, 1, the composition will be 1, 1. And when F and G are onto, composition map will also be onto. So we are going to prove this one. First, let us prove the condition for 1, 1. The other word for 1, 1 is injective or injectivity. Suppose we are going to assume these two functions f from a to b and g from b to c are injective. Now we are going to prove g composition f from a to c is also 1, 1. We already know that to prove a function as 1, 1, suppose if I have a function f from a to b, if I want to say this function is 1, 1, so the condition is whenever f of x1 is equal to f of x2, this should imply x1 equal to x2. That is, distinct elements should have distinct images. So here also we are going to prove this composition map is 1, 1. So I am going to take two elements from the domain set A. Let x1 and x2 belongs to A. So we are going to find G composition f of x1 equal to G composition f of x2. So if we assume this part, we have to prove these element x1 and x2 should be equal. Now we can apply the definition of composition. So this can be written as g of f of x1. This will be equal to g of f of x2. And we already know that G is an 1, 1 map. So whenever we are having G of some element equal to G of some other element, we can conclude that these two elements will be equal. So f of x1 will be equal to f of x2. This is because G is 1, 1. And also we know that f from a to b is also 1, 1. So the condition f of x1 equal to f of x2 will imply that x1 is equal to x2. This is because f is 1, 1. So we can easily observe that we have assumed G composition of x1 is equal to G composition of x2, and we have proved the elements x1 will be equal to x2. This is the condition for 1, 1. So we can conclude G composition F will be a 1, 1 map. Next one, we have to show onto map or surjectivity. Onto means if I have a function f from a to b. So if this function f is onto, then for every element in the codomain, I must have a pre-image in the domain. Here we are going to assume both the maps f and g are surjective. Surjective in the sense it is also known as onto. We have to prove that the map G composition F from A to C is also onto. So onto means, observe that we are going to choose one element from the codomain and we have to find a pre-image. So since the codomain of the composition map is C I'm going to choose one element from the set C. So observe that G is a map from B to C and it is surjective. So if I choose that element from C, I can find one element B in B such that this element B will be mapped to the element C under G. Since G is on 2, there exists one element in B such that this condition will be true. G of B is equal to C. Now we are having one element B in B. So here we are going to use the condition on 2 for the function f. Since I am having one element B in the codomain of f and f is on 2, corresponding to this B, I can find one element in A, that is A in A, such that f of A will be equal to B. So what I am going to show is this pre-image A will be the pre-image of C under the map G composition F. So if I find the image of A under the map G composition F, observe that this can be written as G of F of A, and we already know that F of A is nothing but B. So this will be G of B, and we know that G of B is C. So for the selected element C, I am able to find one element in A such that that element A is the pre-image under the map G composition F. So since this is true for any element C, we can conclude that for every C in C, I am able to find one pre-image A in A such that G composition F of A equal to C. So our conclusion, G composition F is on 2 can be obtained. So this property shows that whenever F and G are 1, 1, we can conclude G composition F will also be 1, 1, and whenever F and G are on 2, G composition F will also be on 2.